The following slideshow will demonstrate how to use the applets to find the theory-based p-value in two different ways. Here we are in the one proportion applet, just like normal. Our null hypothesis in Exploration 1.5 was that half of people would pick heads. We had 88 people in our sample, and let's go ahead and do 5,000 repetitions. No need to animate, we understand the coin flipping process. I'm going to change to plotting proportion of heads and put in my observed statistic here of 0.625 or 55 out of 88 to find my p-value. This is a right-tailed test or a greater than sign because my alternative hypothesis is that more than 50% of people would pick heads. Here we get a p-value of 0.009 because 45 out of my 5,000 dots got a p-value, got a sample proportion of at least 0.625. That's the simulation approach that we've been doing so far in the class. What if I wanted to use the theoretical approach? Well, all I need to do is check the box for normal approximation. The blue distribution that appears in the background is the normal distribution for these data, centered at the null hypothesis of 0.5 with standard deviation square root of 0.5 times 1 minus 0.5 over my sample size of 88. When you do that calculation, you should get something close to 0.052. I get a standardized statistic of 2.35 when I subtract my null value, 0.5, from my p-hat, 0.625, and divide by that standard deviation that you calculated. And that gives a p-value of 0.0095. Notice that the p-value from the theoretical approach and from the simulation approach are very similar. This makes sense because our validity conditions are satisfied. We have 55 successes and 33 failures in our sample. I could also get the theory-based approach information from the theory-based inference applet. I'm in the one proportion scenario because I'm working with one categorical variable. When that changes, you can change scenarios here. I still have a sample size of 88. In the count, I'm going to write the number of successes, 55. Notice that the sample proportion will automatically pop up. I could reverse that and put in my sample size, 88, and my sample proportion, 0.625, and this count number of 55 would come automatically. Click Calculate. Then we can go to Test of Significance because we're doing a hypothesis test. The null hypothesis again is 0.5. My alternative is a greater than sign, so if I click the sign in the alternative once, it changes to a greater than. If I click again, it changes to two-tailed. Recall we want a greater than. Click Calculate. The dark blue shaded area again is the area of my p-value, the area beyond my standardized statistic, which again is 2.35 with the same p-value as the other applet gave us, 0.0095.